My name is Chandandeep Singh, and I have been working in computer vision for some time. I've completed my master's in robotic systems. So, my specialization is in computer vision for robotics applications primarily. And today, what I'll be talking about is how you can start learning computer vision on your own. What are the tools that you might need? What are the steps that you have to follow? Because starting is always a difficult thing, especially for an advanced field like computer vision, machine learning, or deep learning, and so on. So, first of all, let's talk about what computer vision is. So there are a bunch of terms that are being thrown around. Artificial intelligence, machine learning, deep learning. These are just these keywords that are being used everywhere in industry, research, academia, and I'll just quickly try to explain the difference between these terms and how computer vision uh, comes into picture, and how it gets connected to all the other areas that we hear about generally. So the broad category is that of artificial intelligence, and then we have machine learning as a subcategory, and supervised learning, unsupervised learning, and reinforcement learning are the subcategories of machine learning that we know about. And at the same time, artificial intelligence is not just limited to machine learning or using neural networks, but it also has other areas called, let's say, automated reasoning, knowledge representation, and also problem solving approaches. It also has close ties with more mathematical statistics and operations research. And where computer vision actually comes into play is when we are talking about perception of the environment and acting of the environment, especially when acting on an environment also becomes important. Then we talk about robotics, and we are talking when we are talking primarily about perception, then computer vision comes into play. So essentially, computer vision is a subfield of artificial intelligence. Now, how is machine learning connected with computer vision? So computer vision is one area that is dealing with interpretation and understanding of images and videos. And at the same time, we can use machine learning techniques to assist understanding of this process, and I'll talk about how that might work in the coming slides. So there's a really good quote by Fei Fei Li, who says that if we want machines to think, we need to teach them how to see. So this is the whole premise behind computer vision. We want to create systems or machines that can learn to perceive and see the environment. So generally, computer vision actually consists of a lot of different areas. So it's very interdisciplinary. It has, of course, intersections with machine learning, as I mentioned, and it also intersects with computer graphics, image processing, cognitive science, and artificial intelligence, which actually, if you think of the broad picture, artificial intelligence is the broad category and computer vision is the subcategory. But in this diagram, it represents it in a different way. But the main idea that I want to convey is that there are intersections between machine learning and computer vision. So, why do we need to learn computer vision? So for us humans, when we look at a picture, we can perceive that, okay, this is Abraham Lincoln, and we can get to know different features about this, about the appearance of this person. We also have maybe emotions attached to the image. When we see, we also probably link it to our existing set of knowledge. So when we look at an image, we understand it. um, and this is what we want to enable the machines, the computers, to do as well. But the problem is that the computers don't inherently understand an image just after seeing it, because a computer works in numbers, as we need to see. So what a computer would actually be seeing, it is actually as a collection of pixels of different intensities. Of course, it depends on the resolution here, but essentially what it would be seeing is a set of numbers. Now, to appreciate the complexity of computer vision, you can imagine that if you're just given this set of numbers, now you have to make sense of, let's say, what sort of numbers would represent, let's say, the eyebrows, the hair, the jawline, and other features. So it becomes really complicated to teach the computer to understand uh, several aspects of an image or even a video. And this is what we try to do with computer vision. Now, there are a lot of topics in computer vision actually, and which is also the reason why it is a bit challenging to start learning computer vision. So, one of the key things is basic image processing that is actually a part of computer vision. Some people can say that it's a different field, but there are intersections with it. So regardless of how you view it, basic image processing is essential to start learning computer vision. And what we mean by basic image processing, when we talk about image processing, we talk about filtering images, sharpening these images, these basic Instagram filters, for example. You talk about identification of edges, noise removal, structure extraction, extraction of blobs or circles in images, and so on. So these fall under the category of computer vision. The reason why this is important is because uh, even if you use neural networks, for your computer vision problem, essentially you would have to do some sort of pre-processing to make the images or the data set suitable for the machine learning or the neural network model being used. And then another category is that of object categorization. And here we use, let's say, a sliding window based object detection. We use classification with hog feature descriptors and support vector machines. So these essentially talk about using a conventional machine learning approaches or even conventional computer vision approaches for performing object categorization. So the image that you see here is that of hog descriptors. I'll not go into details of all of these specific approaches, but the point would be that I give an overview of all the approaches and how you can actually start learning. So, another thing you might have heard is that of feature extraction. Now, this is when we talk about feature extraction, we are talking about manual feature extraction using conventional computer vision approaches. Face detection, key point localization, corner detection, Harris corner detectors, local feature extractors like SIFT, SURF, etc., come into play. And then uh, deep learning also assists in computer vision. So nowadays, this is when people talk about computer vision, this is what they talk about actually, but there are a bunch of different aspects of computer vision, as we saw as well. So we see here that classification and localization of objects inside an image, uh, identification and detection of multiple objects inside an image, semantic segmentation, which you see here is we are not separating the individual uh, objects or sheep in this case, but rather have a general sort of segmentation of different types of objects, and then instance segmentation. So all of these things are more complicated tasks, and that is why deep learning assists in these tasks. So this is where convolutional neural networks come into play, and also these are also used for pose estimation. So when you have seen these videos where the pose of a human is visible as well. Semantic segmentation, mask RCNN, fast RCNN, YOLO, all these kinds of models, ResNets, uh, these fall under the category of deep learning. But there are also more advanced topics in computer vision, that of using a stereo camera to actually perform 3D reconstruction. And these use concepts like essential and fundamental matrix, epipolar geometry. Also, camera calibration and triangulation approaches would fall under these categories. And then after that, we can move to talk about motion and talking about how segmentation approaches and 3D reconstruction approaches can be done for videos. So we talk about tracking, template tracking, and other Lucas Canada tracking approaches that are used. And then visual odometry, visual slam, optical flow, video analysis, multi-object tracking, and video segmentation. So all of these seem like a lot of things to learn, right? That is why it's a bit tricky to get started with computer vision. So the idea is that you start with learning basic image processing, and then you learn conventional object categorization approaches, and then you move on to learn feature extraction, and then deep learning, which essentially automates the process of feature extraction. Then you can go on to 3D reconstruction, and then go on to more motion driven approaches. So this summarizes all of the different approaches that are existing in computer vision. Now, the typical university courses, let's say, would follow to a certain extent, more or less, they would follow uh, a structured approach where they would start sequentially from basic image processing and go on to, let's say, motion and video analysis approaches. Uh, but my personal experience has been that this is not the best way to learn. First of all, because you would be learning lots of theory in all of these areas, and of course it's very difficult or next to impossible to do projects in all of these areas. So my view is that you first identify what areas you are interested in, and then what you can do is, once you filter out some of your interest, then you can take up a few projects in that particular domain, and take up multiple projects, and then you realize, okay, this is cool, but I don't want to establish a career in this area, and then you can explore more. And this is what we will talk about next. But first, let's talk about what are the applications of computer vision. So these are just general applications that we all know about. Uh, computer vision, face detection, face tracking, object detection. All these things are starting to get embedded in digital cameras and also mobile phones. Uh, Mobile phones, and these applications on our phones have computer vision. A lot of these. Uh, Object detection, face identification applications use this technology. And then we have something that is used in more in the medical sector, for identifying diseases using X-ray images and so on. It can also be used for 3D modeling, as we talked about 3D reconstruction. It can also be used in movies, films, and so on. Then there are vision based interfaces, and of course, it's used in robotics and autonomous driving as well. So there are a lot of different applications. These are just giving a broad sense of. These are just to give you a broad idea of what different applications there are. Uh, and the reason why this is important to know the applications is because essentially, in the process that I will be sharing, you have to filter out your interest, and for that you have to know what are the different applications that are existing. And so you can choose, okay, yeah, I'm interested in robotics and I want to learn computer vision for bin picking, or maybe I'm interested in 3D reconstruction and I want to learn more about that. So this is the whole premise of it. Now, let me talk about how I learned computer vision. Of course, I was enrolled at a university program at RWTH Aachen University in robotics, and so I got the chance to learn in-depth theory about computer vision, machine learning, and so on. And I took multiple courses, but at the same time, I took some additional. Uh, Online courses, the ones by Andrew Ng, for example, deeplearning.ai, and so on, which everyone takes, and probably many of you have already taken as well. So there are two aspects of this university and online course way of learning. One is, of course, you get a really good theoretical foundation, but at the same time you have to do lots of activities which may or may not be related to real world case studies, but regardless, you have to get used to using OpenCV, Python, and all of these NumPy, all of these packages basically. So I did a lot of university course assignments as part of my curriculum, and I did online courses and also took theoretical courses in my university. But I would say if I just this part was not simply enough for me to take computer vision skills to the next level or learn even more. So I was fortunate to get some industrial experience. So I worked as a working student in a few companies, and then I did internships and my master's thesis also in similar areas. And this is where I think I learned the most. So one of the very first projects that I did was using machine learning, a unit model for smoke segmentation. And another one that I did was to apply a visual slam for a drone using a real sense camera. And then after that, during my internship, I did use deep learning and object detection and segmentation models to segment objects inside a heap of objects, basically. And then the robot would pick it based on the grasp points that are generated from these segments. And then after that, I did some more work in object detection and synthetic dataset generation. So this is how I learned computer vision, basically. And by the way, I've also added a link to the courses at my university. The slides and all are available for free, actually, so anyone can start learning. And I would say the theoretical slides are really in depth, and they cover the recent research papers. I think they also have slides for all the past years and so on. They regularly update that as well. So if you're interested, you can also check that. Um, but at the same time, I have created a sort of a system or a framework that would help you immediately start learning computer vision after you end with this session and go about your day. So I'm a fan of reinforcement learning, and there's this concept called exploration versus exploitation that the reinforcement learning agents go through, so as to have an optimal learning rate to achieve the desired outcome. So this is what I try to apply in my own way of learning as well. So the framework that I'm using is that of exploring your interests first. And once you have explored enough and you realize that, okay, autonomous driving, let's say, is the area that I'm interested in, and then you take up more and more projects in a progressively increasing difficulty way, such that you can gain mastery in one area. And here I would also like to point that eventually, to get a job, or even to do a PhD or whatever, you have to have one area where you are really good at, and of course having some overall view of all the different areas is also essential. But you have to have a specialization, is what I mean. So let's say you are a total beginner and you want to learn computer vision. How do you start? So the first is selecting a field of your interest. How would you select a field of your interest? At first, you probably don't know which area you're interested in, right? But you see these videos on YouTube, and you attend these seminars, and you talk to people, and so you realize that, oh, okay, let's say robotics is something, computer vision for drones is something I would be interested in, for example. So what you do is you just choose a project in that domain, and then you learn the necessary theory. And for that, there's plenty of information online. And once you have learned the necessary theory, you can start working on the project. Another optional thing that you can do is you can find an accountability partner. You can talk to your friends, or go on to these Discord servers or Facebook groups or whatever. You can find people who are also starting out, and you can help each other out when you're stuck. And once you finish the project, then is where you have to pause and you have to think, uh, is this an area where I am interested in, where I would like to learn more about? Are you excited by that project or the domain that you chose? And if you did, then what you do is you would take up another project. So another thing to point is that you select a very simple project in the beginning, and once you like it, then you take up another project of a slightly more difficulty. And then if you like it again, then you could eventually be increasing your skill level after every project that you do. And maybe you don't like the thing that you did. Maybe you realize that there's not a lot of opportunities there, or maybe you're just not interested in the project that you did. So you go back to the first step and you explore more. You maybe now you take a different project, maybe in medical image processing or something, and you repeat it the same the same way. So let's take an example. So autonomous driving is something that is growing very rapidly, and we see it everywhere with Tesla and other autonomous driving companies making these announcements about progresses in this area. So you say, okay, I'm interested in autonomous driving, and then you take up a very simplistic project. And of course, for that, how do you know the projects that you have to select? So the idea is to take a very simple project, and I'll talk about how to select projects in the next slide as well. But the idea is to keep the project as simple as possible in the beginning, and not to make it too complex, because if you take up a project that your skill level is not sufficient in, you would lose motivation, because even in simpler projects you might get stuck in the beginning. And let's say you take up lane detection. Now you search online and you realize that you need to learn some theoretical concepts, like it would maybe require basic image processing, like edge detection, hog transform, and these things. So you just learn the bare minimum concepts that you need to learn. And after that, maybe you select an accountability partner. Now, this is an optional step. You can go on to servers like AlphaBot Robotics, or the Building Culture community, or Facebook groups, or you can talk to friends and so on. You can choose an accountability partner as well if you want, and then you start doing the project. Now, I mean, it's really simple to find tutorials on these simple projects. You can find OpenCV tutorials. There are other resources that are also shared online. But the idea is you don't get too you don't hang up too much on the theory. You start to apply these things immediately. For example, there would be packages for edge detection in OpenCV, and the idea is to start coding immediately. And then if you see, okay, there's a some there I need some more theory, then you go back and watch a few videos as well. So this is my approach overall, how you can start learning computer vision. Now, there are a lot of people who would say that you should take the courses step by step and have a really strong theoretical foundation in all of these areas. Of course, you can do that if you have the time, but this framework that I'm providing is more efficient, because you can start to do hands-on work more immediately. Of course, I'm also curious what difficulties you face while learning, um, and what do you think about this framework, if it will be useful or not. So let's now talk about how to select projects. So these are just a bunch of projects that are very commonly used. Of course, cat dog classification and MNIST handwritten digit classification, and face landmark facial landmark detection, automated image captioning, pose estimation, camera calibration, semantic segmentation of objects in bin, cartoonifying yourself, and so on. I mean, the list is endless. But the idea again is to choose the simplest project to start. You can explore GitHub repositories, you can check Medium articles, you can just simply Google it, right? There you will find a bunch of information, but you choose a project and then you stick with it. Another thing that I like to do is to generate ideas myself. So you can generate your own ideas, project ideas. So, for example, you work on your laptop and you think, okay, uh, what if there's an app called app that actually helps you pause your music player without using the keyboard, so you can use your laptop camera to, let's say, do a gesture recognition or something, uh, to build such a system. Now there's already an app like that called Flutter, you probably know about that, but you can come up with your own ideas. And the reason why I encourage you to come up with your own ideas is because you would be excited to do the project and you're more likely to finish it. Otherwise, randomly, if you select, let's say, human pose estimation and you get stuck, or your accuracy is not enough, then you might lose motivation. So this is another thing that you can consider. Of course, you can also Google search your projects. So there are two primary ideas: choosing a very simple project in the beginning, and choosing the project you're most interested in. So choose a project you're interested in that is simple enough as well. uh, Now there's a lot of so it's not just for theory. I've written additional resources. Theory, it's actually some of these resources you can start to use uh, for your projects immediately. So talking about theory, so there's these couple of YouTube channels that you know about. Free Code Camp, it's actually also a very hands-on tutorial based way of learning. They have some tutorials on computer vision and then first principles of computer vision. This is more of a theoretical lecture based learning. And then there's these proper lectures called Ancient Secrets of Computer Vision that you can check. uh, of course, there's this Professor Cyril Staknis from University of Bonn. You can find his lectures as well online. I used to refer them. They're very detailed. So especially if you want to go into research, these lectures would be helpful. But if you want to just get started with doing projects, I think for me personally, I found this PyImage search as the best resource, where you can start to use OpenCV, computer vision, and deep learning, because they have very structured step by step guidelines on how to start doing a project. Even they even have tutorials on installation of OpenCV and its dependencies, because initially that could also be a problem. And another one is Augmented Startups. This is another good website. They have a YouTube channel as well, and they teach how to build projects, how to use different models, YOLO, Mask-R, CNN, and so on. So, and of course, you can go directly with OpenCV tutorials. It's very detailed and very hands-on. So these are some additional resources that you can refer to. But again, my view would be to take a project of your choice and progressively increase your skill level and the difficulty of the project. And these are some of the references that I used in making this presentation. I think there were more references, but I couldn't add it. But I'll add it later and maybe share it back with you. So that's it from my side. And if you have any questions related to any of the slides or anything, we can talk about it.
Wonderful, Chandeep. Like, uh, anyone has any questions regarding computer vision, or if someone is yet to get started with computer vision, or someone is already into computer vision, you still have some roadblocks that you would like to discuss with Sandeep. In fact, we can all come together and maybe we can have a good discussion right now. It would be a good chance. We could discuss a lot of cool things right now. Anyone? Anyone with
Hello,
any?
sir.
Yes, yes. Go ahead.
Sir, my question is, sir, so if I start the computer vision with the robotics, so just assume, sir, I build that one robotic arm, and I want to implement the computer vision with it. So maybe I put a pen by this robotic arm. So how I control the robotic arm by this computer?
So your question is that you have a robotic arm, but you want to control the joint movements using computer vision, right?
Yes, sir. Yes, sir.
Yeah, so you can use some specific approaches like visual servoing. You can Google it, so the idea is that it has to be an integration of computer vision and control. So visual surveying is one really good option that you can consider. But have you built the hardware yourself, or you're using a kit, or what exactly are you using?
Uh, Sir, I just the starting state, sir. I build the hardware, but sir, I stuck in the this implement the computer vision part.
Okay, okay, okay. And have you done some computer vision projects before, or is it just you want to start with it
Hi,
using this?
yes, sir. Sir, by Qiskit file. So just I am the beginner on this domain, sir. So
Yeah.
I just use the hard cascade file so to detect some object in various object, like if they are one car, so I just put some picture with the hard cascade file, and they detect the just one car is there, like that, sir, only.
Okay, 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 okay. Yeah. But you want to work. You want to explore the robotics, computer vision for robotics area, basically, right?
Yes.
So yeah. So basically, let me share the screen where I was talking about the framework. Yeah, so here your interest is in robotics, right? And you want to use computer vision to actually control the robotic arm. So what exactly do you want to do? So the camera would be mounted. First of all, you have to figure out the hardware arrangement, I think, so that you can define the problem. So is the camera on the end effector, and
Yes.
then you want to, sorry.
So I just mount the camera on the end effector.
Okay, okay, okay. And what exactly do you want to do? So you want to capture images from the end effector camera, and then what exactly do you want the robot? Do you want the robot arm to track an object and move accordingly, or what specifically do you want to do?
So first of all, my project is the harvesting robotic arm, sir.
Okay.
Okay.
Yeah.
So, so if there is one flower in one tree, sir, so my
Mhm.
aim is find out the coordinate uh, of this flower by this robotic arm and the camera also,
Okay.
and
Uh,
and
yeah.
and then the
Yeah. Yeah, please go
robotic
ahead.
joint movement also to plug the flower from the tree, like that, sir.
Okay. 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 So so what you are telling is actually not using computer vision to uh, control the robotic arm. I think that's a different so visual servoing is not what you need here. So what you would be doing is basically using deep learning for object detection. So let's say we have a flower, right? So you'd be using deep learning for detection of that object, and then eventually find a, but yeah, so here you have to figure out the hardware first, because you also want to have a gripper, right? So how are you
Sir,
going to
yes.
arrange that? So I think the first step for you would be to define your project very clearly, whether you really want the camera on the end effector, or can you place it externally. Because for harvesting type of projects, what is generally done is they make the camera, let's say overhead, it's mounted in a fixed way. So just imagine the camera is mounted overhead, and let's say we have a plant or something, and we have flowers on that, and then the robot arm end effector has the gripper actually and not the camera, right? So you would use the camera, the images captured from the camera to train a network to identify flowers, right? So you would use supervised learning for that, and you would label those images and feed it to the network. And then after that, what you would do is, once you have, let's say, a flower, uh, then you would pick out, then you would find out the grasping point using the detected object or the segmented flower, right? Once you have the grasp point, then you would feed it to the robot, and then would be the control part. So here the control and computer vision are not working simultaneously in this case. Does it make sense?
Yes, sir. I got it.
So but
I
this
got your
is
point.
this is the project that you want to do, right? Or
No, sir. I already built the project actually, but I did not completed the computer vision part, sir.
okay,
So
okay, no,
that is
no,
not.
but this is exactly what you want to do, right? With harvesting, it identifies and then grasp point and picking, right?
Yes, sir.
Yeah, yeah. So yeah, the first step would be to decide actually where you want to place the camera, like setting the hardware stuff, fixing it fully, and then you go on to the computer vision part, and you forget about grasping altogether, right? Uh, of course, you have to take that into account as well, but you first focus on training a model to identify the flowers, and then how you can use the output of the model. Let's say if it's a segmentation or object detection or a contour, whatever you're getting, you try to get a grasp point from that, and then you do the grasping by the robot. So just break it down into 3 or 4 parts, otherwise it gets confusing, right? So yeah.
Yes.
Yeah,
Okay.
Chandandeep, I think we'll go ahead with other questions. I think there's few questions in
Okay.
line. So,
Yeah, sure.
Rohit had like raised his hand. So,
Yeah,
go ahead and
yeah, I so please let me know if I'm audible.
yeah, yeah, audible.
Yeah, I'm
Yeah,
inside
you're
a train actually. So, hello Chandan sir. Actually, I started a project in computer vision around 6 or 7 months back, and at that time I got a real hard failure in that because the project was to, it was related to semantic segmentation, and I was expected to use mask RCNN in that, but my knowledge on deep learning and computer vision was not enough. So I was very much heartfelt kind of person. So I took on, means I gave up on that project and I went on with embedded systems. I did some internships and all, and then I decided to take a break because I was completely confused what to do. I am having a lot of knowledge of lot of fields, but I was completely my. I took break on in Isha Foundation, if you know about that. And I just came out of the Isha Foundation, and I was thinking of going with mobile robots. Means my main interest, I think, is not. I think I just means went through all the, means I just seen my past that what I have done and what are the all the mistakes. Means as you told us that don't take a big project, you will get confused and you will be very much heartfelt kind of thing. So those things happened with me, and with projects also. Means I was choosing big projects, not focusing on basics. So that I'm planning to do. But one thing I realized is that I want to go with means mobile robots and SLAM motion planning and computer vision in motion planning, especially. I want to go with that. So I have three things in my hand. Actually, I have a project which was provided to me from Alphabot community. It was this same project which I was talking about, that I have to use mask RCNN to calculate the number of vehicles in a road. So that thing I want to do. Plus, I participated in a kind of competition. It was from NXP, and it was named as Artificial Intelligence in Mobility. So I have a simulated problem statement in which we are given a car and we have to use uh, this computer vision to track the path and object detects and to complete the trajectory in a given amount of time. And in a manner. So I want to do all these projects after I go home and start doing my project. So I think my this is the means this is the first meeting after I'm coming out of the break. So it was my great pleasure to have a mentor like you at the first. So could you please guide me with that?
Okay, yeah, Rohit, thanks for sharing your overall journey, basically. Uh, what I understand is actually there's a lot of noise.
Oh, I'm sorry.
Yeah. What I understood is that you want to learn mobile robots, and you have a lot of project ideas that you want to learn, but you take up bigger projects and then you get stuck on that, right? So yeah, I mean, my suggestion would be to take a simpler project, or if you want to take a big project, have at least a few friends with whom you can do that, so that when you get stuck, at least you can get different perspective. And another thing about mobile robots that I can add is that of course you would need a hardware for that, but to start you should just focus on uh, using ROS for that, for mobile robots, and you can use Visual Slam packages to actually just make it work. It would be very simple to start with. It would not be very complicated. And you, if you want to go into mobile robots, I think mobile robotics, you would be needing some ROS knowledge as well. So take up a very simple project, let's say Visual Slam for Turtlebot robot, right? And you can find lots of tutorials online for that. And once you have done that, okay, now you maybe want to take it to another level. So you expand on it. You search what are the different things that you can do. Maybe tracking and following the mobile robot maybe follows uh, some human or something like that, or maybe you buy an actual hardware and do it on that. So that would be the thing. Did I get your question correctly, Rohit?
Yeah, you got my question. You are going correct. Yeah.
Okay.
Thank
Yeah.
you, Rohit.
Thanks,
I
Rohit.
think Krisha has also raised his hand, but before that, I think there were a couple of them who asked in the chat box. Could you go through the chat box? Should I just read it for you?
Yeah, sure. I'll go through it. So Siddharth Dayasagar is the first one, right?
Yes, yes.
Should I first know theory, or can I start learning by doing projects? This is a very common question, right? So for me, how I learned was, of course, I was in the university, so I learned theory, and then I did some assignments of all the theory that I did. But for me, what was the best way to learn was when I actually got to work in industries and I did projects actually. Because of course you know theory and it's good, but eventually if you work for a company you have to have the skills, and I would say just start doing projects, and you can do both of these things simultaneously, but I would say focus on projects. I hope that answers your question.
Uh, yeah. Krish, you can go ahead. Actually, after that, we'll go ahead with other questions.
Yeah, thank you. So I wanted to know that which programming language had you used to start with computer vision?
Yeah, that's also a good question. So it depends on what exactly you're doing. If you're going to be using computer vision for hardware, let's say robotics, or I don't know, optical instruments, or other sort of gadgets, I guess C++ is more widely used and it would help you. So I think for computer vision, C++ is really a good option, especially when you want to go for advanced projects, or if you want to go for a PhD, that is definitely the thing. But I would say to start with, go for Python. Start with Python, and then if you can take these machine learning and deep learning projects in Python and OpenCV. You can do these projects, and then once you are comfortable with Python, then make a transition to C++. So yeah, this would be my suggestion. But for computer vision, I would recommend that eventually at some point you switch to uh, C++, or you also develop some skills in C++.
Yeah, thank you. And do you recommend any books by some authors?
Yeah, the books are standard. So the one is, what was it? The pattern recognition, machine learning. I forgot the author name. But I would not. Yeah, I don't. I would not recommend you reading all the theory from the books. If you can find a book which has lots of projects and step-by-step tutorials, I think you can search for that. But apart from that, if you're not going into research, I would not recommend you spending too much time on theory, and use the book when you get stuck with some of the problems to see, okay, yeah, this is the theoretical concept that I was missing.
Thank you.
Yeah.
Thanks,
And
Krish.
Chandradeep, we can go ahead quickly with other questions. We have less time. So we'll be closing off soon.
Okay.
Yeah.
Yeah, so if we wanted to go for masters in computer vision and robotics, what level of knowledge should we have in computer vision? Well, it depends. So I can tell you my journey. So I didn't have any experience in computer vision before I got admission into robotics, because yeah, it was robotics first of all and not specifically computer vision. So the prerequisite was that I work in something related to the course that I was trying to get admission into. And so I worked in mechanical design, where I worked on some electromechanical mechanisms and other things related to mechanical design, and I did some robotics projects in my college. But I didn't work with computer vision. And if you're, let's say, going into robotics, you don't specifically have to have computer vision experience. You could have worked in embedded systems, and you could, even if you have good profile, I think you can get an admission in robotics. So because robotics courses are also very interdisciplinary. For example, my course had multi-body dynamics, computer vision, machine learning, of course, and um, but also electrical drives and things from all different fields. So I would not say that you have to have computer vision, but uh, if you want to gain experience, I think Coursera courses or PyImage Search, you can get certification from that. That would be very good quality resource, actually. Okay, I hope that answered. And the next one is, any suggestions for a context analysis model, one that gives an image description, give an image and have it tell you what is going on. Polar bear chasing after a fox, for example, would be a possible result. Yeah, so I have not specifically worked on a project like this, but what would be beneficial is if you go into searching for RNN models, recurrent neural networks, or even LSTMs in that regard. I think, yeah, just search for RNN models. I don't have any specific model suggestion because I have not worked in this. Uh, Another one is from Rajiv. I don't have any experience in CV, but would like to learn and then explore, probably in the field of robotics and autonomous cars. But I often end up getting confused in selecting which resource to start particularly. Yeah, that's the point, right? So can you share some insights on how to choose a specific resource, and can you also share your suggestions too? So again, the same thing is, don't focus too much on selecting the right resource, because all of the I mean, if there's a resource from one university and from another university, they would all be most likely very good, right? So the idea is not to overthink. Just pick a project. Don't like it, leave it, right? Just try to keep it as hands on as possible. And some of the resources that I can definitely recommend is PyImage Search. This one, particularly because it is exactly a project based learning approach, and also I think augmented startup. So you can start with not going into the core mathematics, or taking textbooks and reading all of that, but rather taking OpenCV projects from these tutorials, where they guide you step by step how to learn. So can you share some insight on how to choose a specific resource? Yeah. So resource wise, these would be my suggestions, but don't think too much about choosing the right resource. What are the expectations and requirements for joining in the role as a computer vision engineer? So um, yeah, so the requirement would of course be that you have some experience before in computer vision projects. That is the reason why try to emphasize the importance of doing projects, right? Because once you have the project, build a portfolio, build a github page, or just have it organized on your GitHub repository or something. And when you have worked on it, then you can of course explain it to the employer. And taking up additional courses also helps. But compare these two scenarios, right? So one guy who has done computer vision, he has taken all the courses in the university and with excellent grades and everything, maybe also taken some online courses, but he has no projects. And the other guy whose grades are maybe not that good, but he has, let's say, 5 to 6 different projects or even similar projects, but in computer vision. So yeah, just I think requirement would be focus on skill development. And expectation, I think by expectation you mean after you start working, what to expect. So it depends, I think, on, of course it depends on the company. In a startup, you can expect that you would probably be involved in other areas apart from computer vision as well. In a bigger company, maybe you will be just focusing on computer vision, and maybe in a different role you can have to focus on something managerial but also software. So it depends actually. I think that's it, right, for the questions. So yeah, I think there's one question. So this is a continuation of the master's question. Is work experience important for masters in particular field experience, especially computer vision and AI related topics? Yeah, so as I mentioned, like you don't have to specifically have experience in computer vision to get a master's in robotics or AI, because because they understand, right, that you want to study it, and the reason why you want to study it is because you don't know it already, right? So if you the idea is you have to demonstrate your motivation and your work ethic, which you can demonstrate by having worked in an R&D, let's say, in a similar area. But it doesn't, I think, have to be specific to computer vision. Of course, if it is specific to computer vision, it helps, and it also depends on the university and all. So yeah, that would be my take. How to maintain motivation for CV? Did you do any exercises in what do you mean, Krish? How do you maintain motivation for CV? Like when you get stuck, right? Um, yeah, I mean, it can be hard sometimes because the debugging takes a while, and maybe you're stuck at a problem for several days, but you have to grind through it, and then eventually you'll get to see the results of your amazing work or whatever you're doing, object detection or whatever. So
Okay.
yeah, that would be it.
I think we are way over our time. It's been almost
Yeah.
our time, so I think we can stop the questions here. Uh, I'd like to personally thank you for coming over our community and giving a session on computer vision, especially getting started. Right. So I hope this has been very useful to people who have joined. I'm looking forward for having Chandradeep again someday for having a little more advanced session. So you people who already had experience can come, maybe some kind of hands-on maybe. So whenever Chandradeep is next available, we can definitely do that. Thank you, Chandandeep, for coming over to our community, taking so much of your time and delivering this wonderful piece. Um, I mean, I think that's it from my side. Any closing sentence you would like to tell Chandandeep?
Yeah, sure. First of all, thanks a lot, Akash, for inviting me to the community. I think this is really good community that you are building, and a lot of people are also very excited to learn. So hopefully the presentation did give you some idea on how to get started. And
Definitely.
of course, I'm open anytime if you want to invite me for another session. And also, Akash is also welcome to join our building culture community and share his ideas with our server.
Sure.
Basically.
One more thing, definitely, Chandan, you might can like share your link to your community in our community. You can just put it on the one of the chats. Chandandeep is also building a beautiful community, very vibrant community with a lot of events. So I think a lot of them would be interested to join your community too. So you can definitely go ahead and share your link to your community so that a lot of interesting people can also join your community.
Okay, perfect. Yeah, thanks. I'll do that. And likewise, you can also share your link. So it will
Yep.
be
Okay. Thank you guys. Thank you all for joining. Thank you, Chandandeep, for joining. I think we can close.
Thank you, guys.
Yep.
Bye.
Thank you.